Hello, everybody, and welcome to our first indoor, online, offline, in-person session of the Bulgarian Java User Group. I'm sitting here in the awesome office of Data Art here in Sofia to present our next speaker and our first speaker after the pandemics. But first, I'd like to thank Data Art for hosting this event, for providing all the beer and everything afterwards. And I'm going to give first the stage to Denise, who is going to say a few words about Data Art. Denise. Okay, thanks. I hope everybody heard you, although I have a few doubts about it. Think you are muted. Well, this happens. It's the risks of the live show. Okay, but yeah, Denise was very happy to host and is still very happy to host us and wants to wish us everybody a uh, great time and great holidays afterwards. And without further ado, let me welcome our great friend and our constant speaker at J Prime, which, by the way, J Prime is going to happen this year, uh, in next year, actually, in May. And the call for proposals is already open, call for proposals. But yeah, Milan, our great friend, is here in Bulgaria for a few days. And we are going to be honored for him to speak to the Bulgarian Java User Group. So yeah, Milan, go on. Welcome. How are you?
Hello, thank you. Thank you very much for having me. I'm not sure if I'm live already and can start. I hope we can. Hello, welcome everyone. Thank you for joining me today. Thank you everyone for joining me online. It's a great pleasure to be here in Bulgaria as usual. Whether that's the J Prime or the Java user group, it's always nice to meet with the folks around here. And this time I'll be talking about events and everything related about events and event driven. I hope you enjoy that. And I would like to take you for a journey through the event land. So let's get started. And as with every journey, it starts at the door. All right, so here we have a door which has an ID 28 and it's yellow. Oh, wait, it's red. Okay, so what just happened here? So the door just changed color. Well, I mean, that's okay if you only interested in what is the color of the door now. That's all you need to know. You look at it, you look at the data, door 28 is red. But if you are interested in how it became red, who's responsible for it becoming red, when it became red, and well, what color was before, you basically don't know. If you store state, if you only know that door 28 is a certain color, that's the only thing you know, but maybe you want to know more. So how about instead of storing state, we are actually saying something like, Joe painted door 28 red yesterday. Now, that is a different way of providing the very same information. From that very simple sentence, you can deduct the door is red right now, but you also can conclude who actually made it red when, and by what means it was painted, right? You may not immediately be able to tell what color it was before, but if that was your way of storing information, like recording what has happened in the past, you can search through past events, and you can at some point in time find an event that says that the door was yellow, right? So from there, you can figure out what the color of the door was before. So I use the word event several times. So what we are talking about here? Well, event is essentially something that has happened in the past. And why is event and events in general, why are they becoming so popular, and so many people and so many technologies are these days talking about events and event driven? Because of this fundamental characteristics. Events are naturally immutable. I mean, something happened. It cannot unhappen. You cannot change it. You can do something else to mitigate the outcome of that event. You can have a compensating action to restore the state as it was before the event, but you cannot undo the event. You cannot change the event. Something has happened. That's it. It's history already, right? So, as Martin Fowler says in a presentation of his, that characteristics of events makes them a first-class thingamajig, right? It's something that you can now talk about. You can present in software architecture. You can refer to in both in your design documents, but also in your software. Please don't break things around here. So events have become so significant in software design as a concept because of these characteristics that during the last several years, a bunch of things have emerged around events. I'll start with those that are related to design. Not yet. We're not yet talking about developing systems, but designing systems. So the first one I want to mention is an event storming. I'm not sure if you're familiar with event storming, but event storming is essentially a process to do a way to do a business process discovery. So you basically look at a domain and you decide, or you identify what can happen in that domain. What are the things that can occur in that domain? And then you try to model the whole domain based on the events. Event storming was introduced by Alberto Brandolini back in 2013. And it's promoted, and it's essentially adopted as a way to build a shared understanding of the domain. You start by identifying the domains, and then based on, by identifying events in the domain, and then model the whole domain based on that. That's why it's called event storming. It's like you do brainstorming based on events. It typically uses a board with sticky notes, and you just put like this can happen and this can happen, and then you reason about why it can happen, who is causing it to happen, who needs to react when it happens, and that information collected, just starting from the what can happen, allows you to build a model of your domain, and then use that model in your application. And while we are at modeling, there is also event modeling. Event modeling is a little bit different approach. It is referred to as a blueprint for a solution. So it was introduced by Adam Dimitrich in 2018, and it's essentially like some people argue that they're covering like event storming and event modeling are covering basically the same ground. Some people saying that they're like different, but they're very similar. Like what event modeling does is it starts with events, it treats them as a first-class citizens, and it puts them on a timeline. And basically, it doesn't have to be very precise timeline, but it kind of tells you that happens before that, or in relative terms, right? And when you put those events in the timeline, you start modeling like, okay, what is the component that caused an event to occur? And then what are the components that are supposed to react to those events in some form or shape? And where the data comes from. So you can even model the front end with that approach, basically like forms or user interfaces, because you know what the data is, what data to contain events, what data is needed, so you can actually model the whole flow. And so it treats the events as the source of truth. Every single data that the system needs to store in order to function is essentially stored as an event. Like something happened and it's immutable, it never changes. There may be another event undoing it, but event itself never changes. And then just an interesting anecdote here. Adam tweeted some time ago on Twitter that they were doing a session on event modeling, trying to model a zoo. And in the discovery process, they discovered this event. I mean, would you think of something like that if you were to just design a system? Yeah, I'm not saying it's realistic. It's just like an illustration of how designing a system based on event modeling or event storming, for that matter, can actually help you discover things that otherwise could go unnoticed. So, event driven. What is event driven? Yeah, well, it's a popular term these days, but what we are talking about when we talk about event driven. So here is the thing that we were discussing so far: an event, something has happened, all right, and we have something to refer to that thing, right? We have this information somehow, something that represents it, and then we have some sort of components that are producing these events. They are basically the ones who notify the rest of the world that something has happened. And then there are the consumers, like some other components that are receiving those events and reacting accordingly. Now, I would like you to think about those in terms of roles and not actual components. So a component can play both roles. It can be a producer and a consumer at the same time. We're talking about the role they play and not exactly the type of component, if you will. So how does these things communicate with each other? Well, they typically send messages, right? In order to notify about event, you send a message, and you typically have something like a message router in the middle that knows how to transfer the data from one component to another. Right? I'm explicitly saying message router and not event router, and then there's good reason for that, and we'll talk about that a little bit later. But the most impatient of you are now thinking, yeah, of course, that's Kafka, right? Yeah, well, I mean, it can be Kafka. Nothing wrong with that. Kafka is pretty good at doing this, but it doesn't have to be Kafka, right? So back to event-driven. Event-driven is essentially a few things. It's a buzzword, first of all, and I'm not saying that in a bad way. I mean, but buzzwords are not bad. If you are to pitch a product, if you want to get your stuff to be noticed, it's perfectly fine to use event-driven, as long as you are event-driven, of course. We use it ourselves in our materials. It's popular, it's attractive, it's catchy, so it's okay. But it's not a technical term in that context. It's more of a marketing term, if you will. What else event-driven is? It's a false claim. And again, that is technically speaking, because it gives you the impression that everything's driven by events. And that's in fact, that's not the reality. In fact, everything's driven by decisions. Now, you make a decision, a human makes a decision, or a system, an algorithm, or artificial intelligence, or something makes a decision that causes an event to occur. So everything is actually driven by those decisions and not by the events themselves. Events are basically a representation of the outcome of the event, of the decision being made, right? So when we say event driven, a lot of people are like, oh, let's do everything with events. Yeah, events are very helpful, but they're not the driving factor. Just keep that in mind. And another thing event-driven is, it's a polysemy. Basically, it is a lexical ambiguity, right? When you say event-driven, there's no hard definition of what it is. Like, we can have a conversation with someone, and both of us can say event-driven, and each of us can mean completely different thing, and both of us can be right. Right, so it's not that it's a defined mathematical expression, no arguing about it. It's essentially an interpretation. As a matter of fact, Martin Fowler did a very good talk several years back called "The Many Meanings of Event-Driven Architecture." He was actually explaining exactly this, how he was talking to and his colleagues. They were talking to different people, and everyone was using the term event-driven, and actually it turns out everyone was meaning something else by that term. All right, so he actually went and defined a few more precise terms in that respect. And first of which is event notification. So event notification is basically giving a short notice via an event. So basically sending a message to someone, informing them that something has happened. And typically that is short because it's just a notification, right? So the approach follows the basic principles of any event-driven system. So a component or an actor publishes an event, a subscriber receives an event, and there is no need for response. And that's crucial in any event-driven system. You send a notification, you tell the world or someone that something has happened. You don't expect them to respond to you. You don't expect any sort of response, right? Now, people argue that order of publishing events is not important. From my personal experience, most of the time, actually, it is important. Most of the time, you actually want to know what happened before or after something else happened, right? But apparently, and probably, there are systems where the order is irrelevant. So, I'm not going to argue about that. Just so you know that order may be a thing that you have to take into account when dealing with events. But event notification is essentially, if you have LinkedIn, that's essentially what LinkedIn does. It tells you, someone saw your profile. Thanks, LinkedIn. Very useful information, right? What you need to do now is go on LinkedIn and actually ask LinkedIn who saw my profile, right? So it's just a notification. It carries no value as such, right? So the process goes like this. The producer sends you a notification, right? But what you need to do is you need to go back to the producer and actually ask them for the actual data. Meaning, your consumer needs to know where the producer is, what language it speaks, how to communicate, what protocols or whatever other things are in place. And it needs to initiate a communication back to the producer and say, hey, I got your message, now give me the details, right? It's a useful pattern. It's not bad per se, but it's somewhat limited in this respect, that the consumer needs to have information about the producer. Now, to make this a little bit more flexible, there's another pattern called event carriage state transfer. Now, event carriage state transfer is more or less the same thing, except we don't send a short notification, but we send all the data. It's kind of giving someone a pen drive, say everything you need is here, and go figure it out, right? Then the consumer actually does not need to know anything about the producer, because presumably all the data that the consumer needs to perform an action or do whatever it needs to do is already provided with the event itself, right? So it doesn't have to be all the data, in a sense, all the data available. It has to be all the data that the consumer potentially needs, right? So this is more beneficial in a sense that introduces a decoupling from the consumer and the producer. Now, the producer does not need to know anything about the consumer does not need to know anything about the producer, because it's provided with all the information. There's no communication back, so greater resilience, reduced latency, all the benefits of the distributed systems, and of course, all the drawbacks of the distributed systems. Particularly, there is a lack of strong consistency. Now you are detached. You don't know what changed from the time someone sends you all the information and the time you are actually processing it. Things may have changed, right? So you can't rely on strong consistency in this case. Nothing wrong with that, but you just need to be aware that you are in the land of eventual consistency already. So that's how it looks comparing to the previous one. You get all the data and then you store it somewhere at some place. Now, what you store on the consumer side, that may be all the data you have received. It may be a fragment of that data it's important. It may be a data that you have already processed and interpreted in some way, and you store it the way you want to use it later on. That is up to you. The key part is there is no need to go back. So you get theoretically you get everything you already need. Now these two approaches brings an interesting question. Where is the source of truth? Like, how do you know what's true and what is your perception of truth, right? So if you do event notification, then the truth is all on the producer side, because everyone needs to go and ask them anyway, right? So you essentially, each truth can only have one source. But if you do event carriage straight transferred, because you copy and persist the data on your side, now you have, for each truth, you have two sources. You have some data stored here, some data stored here, and you don't know if they're consistent or not. Right? So illustrating that a bit, that is the source of truth for event notification. That's there, right? And that's you want to know something, you go ask and you get it from there, and you know it's true, right? But when you do event carriage state transfer, now you have the data there, and you have the data here, and you operate on this data, but that data may have changed in the meanwhile. So which one you trust if you need to make a decision? So there is a way to mitigate that, and it's known as event streaming. Now, event streaming goes a little further and says, okay, what about we introduce a message persistence inside our message router? So every single message that goes through the message router is being recorded there. And that essentially kind of gives you a stream of events, right? Then the consumers need to know where they are when reading that stream. They need to know their position. So those are the events I have read so far, and give me everything after that, right? Now, if you do this, then you don't actually have to store things in here, because you can always read them from the stream, right? You can every time go and say, give me the events from beginning of the world till today, or for the last day, or since number X, right? And so this is the time where a lot of people go like, yeah, of course, Kafka, right? Yeah, sure, Kafka does that too. I mean, again, it doesn't have to be Kafka, but you're welcome to use Kafka if you wish. Now let's go back to the source of truth, though. So with the event notification, nothing actually changes. You can introduce a stream in between, but it doesn't really matter. But if you do event carriage state transfer, now you no longer actually need this data. This data here, storage here, does not become is no longer crucial for your operation. It's more of a local cache, right? So you get the data from the stream, you store it here because it's convenient to work with it, but you can at any point of time delete this and reread the stream and rebuild it, right? So it is not your source of truth per se. It's just more for convenience. So your source of truth now becomes the event stream. That's where everything's stored. You know what happened, when it happened, who sent it, what information contains. But that does not eliminate the other source of truth, which is on the producer side. So you still have two sources of truth, but they are just in different places, right? And of course, that's the time where someone's going to jump in and say, yeah, no, that's how Kafka does event sourcing. And this is where someone else would say, I'm sorry, but that's actually not event sourcing. And here is the debate about what is and what is not event sourcing. So let's dig into that. So what is event sourcing? Now, in order to actually do event sourcing as it is defined, you need to do one more thing. You need to get rid of that first source of truth. You need to keep one source of truth, and that's going to be the message stream inside your message router. But then again, how do you do that? How come a component that is supposed to send notification work without actually having the data that it needs to make a decision and send an event? Well, the same way all the other components do. It gets it from the event stream. So you have the stream, you send an event, all the events are stored in there, right? And there is nothing that prevents the producer to rebuild their state by reading the past events, except they don't need all the past events. All they need is the events that they have sent in the past. Because you start a clean system, the producer has no state. It calculates it, it receives some data from somewhere, it sends an event that something has happened, that event is stored here. The next time the producer is accessed, it reads the state, it reads the own events, the events that the producer has sent before from the event stream, brings up a state to the point where it was last time, and then applies the operation that it needs to apply. If you think about it, that's essentially what the producer does as a normal operation, except it does not read it from an event stream, but reads it from a database or a file system or some other place. But if you remove that and make the event stream the same source of truth for everyone, then you all of a sudden have a single source of truth for your entire system. Everything that has happened in the system is here. You know exactly what happened, when it happened, who made it happen, why it happened. It's all here, right? You don't have to go into different places and match the data between different components. And that's essentially what is now known as an event store. It's a place where you store all the events. And then, again, a lot of people attempt to do this with some Kafka, and some sort of storage like Mongo or database or something, and it's doable. It's not a rocket science, but it's kind of like defeats the purpose unless you are in the business of making event stores. It's just a lot of work. So why it is a lot of work? For several reasons. An event store needs to be an append only. So the event store itself must prevent you from modifying things, because you can't change history, right? So if you use database, you can do it with some sort of permissions and things like that, but technically it's always possible for someone to go in the database and modify past event, right? And then all the data after that becomes corrupted, essentially, because you made a decision based on data that has changed in the future. but it's like changing the law with a past date. Question?
No, blockchain.
All right, I haven't heard that one. Blockchain. Yeah, I think we can discuss that.
You want it to be metaverse?
Yeah, I guess blockchain will do. Although, yeah, with the energy power thing, anyways, but so this is the thing that an event store needs to do. It needs to be an append only. Cannot modify events, cannot delete events, cannot update events, cannot insert events anywhere in the past. You can only append them at the end, right? Like Kafka. Then it needs to give you a full sequential read. You need to be able to give me all the events from the first to the last, right? I mean, if there are trillions, zillions of events, it's up on you. Go read them all, whatever time it takes. But the event store as such needs to give you the ability to do so, right? But it also needs to be able to do specific replays per component. So you need to be able to tell the event store, I am this component, and I want all the events that are relevant to me, right? So it go through all the events, or a period of time or subset, but give me only these events that I would normally consume, right? So that's crucial if a component needs to rebuild state, right? Just throw the cache and read it all and rebuild the state. The same thing goes for the aggregates. Now I'm using the DDD lingo here, but essentially those are the components that produce events, like the producers. They need to go and to the event store and say, okay, give me all the events that I have produced in the past, because I need to recalculate my state in order to proceed with an operation. Now, as we said earlier, that may be a lot of events. Like we have customers with, I don't even know what, because I'm always confused with the English, like what is like a billions, millions, zillions, whatever, but it's like a lot of events. And it's obviously at some point in time, it becomes almost impossible to read all the events all the time. So what an event store needs to do, it needs to provide a snapshot. So you typically are interested in replaying a last X event. That may be last week, that may be last month, that may be last 5 minutes, whatever your domain dictates. But typically those are the events that you want to get like one by one, all right, and operate on them. And all the other events are for you just to build a state. So if the event store can do this for you, can take a snapshot at some point in time and basically say, okay, this is your state at this point, and you request the events, it gives you the snapshot and then gives you the events that follow after the snapshot. That speeds up a lot. But snapshots they're just there for the purpose of performance, right? At any point in time, you can delete all the snapshots, and you can go and say, okay, build me a snapshot here. Like it makes more sense to do snapshot monthly, but now it makes more sense to do it weekly or daily or whatever. So snapshots are not like the data; they're just way to make it make the access faster. It's a performance optimization.
But to make snapshot, you need to know the structure of the data, right? You cannot.
Yeah, I mean that is essentially snapshots are for the aggregates, for the people, for the producers of the event. So essentially, they have to initiate the process of or tell the data the event store how to build a snapshot. It's not a knowledge that the event store itself has, but it has to provide you with the ability to request it. I said, at this point, I want a snapshot, and that's the structure, right? And then when I request the data back, give me that data. And yeah, also that's another reason to redo snapshots is if your data structure changes. And there's also other things which I'm not going to cover in this talk, but there is, and I'm blanking on a term now. upcasters. There's another concept of an upcaster that's basically a component that can convert a past event, like the event that has happened in the past that had different structure, to an event, to the same event of today after the structure has changed. So there's a lot that may be going on behind the scenes here, but the point is, if your event store does not provide you with the tools to build and store those, it's on you. You have to do this manually inside your application. It's not a rocket science, but it's work. And so it's better to have the event store that actually can do this for you. Last but not least is partitioning and archiving. So if you are into, for example, building financial systems, accounting or stuff like that, you should be familiar that there's a notion of closing the year, right? So we close the year. The data from the last year is no longer used in our day-to-day operations, right? We start cleaning with a new database, but we can't throw that data away. We still need that data for whatever historical purposes, right? So a good event store is going to give you partitioning. You can define like the data from here is less important, the data from here is more recent or whatever. The other thing is that you can, if you have partitioning, you can get old data and move it to some less expensive storages. Like if you have data that's like 10 years old, right, and you don't use it on a day-to-day basis operations, you can put it on some archive somewhere, so you never lose it, but it's not costing you anything in operations. So now we have an event store, we have all the process. Are we event-driven? Like, is that what we from now on going to call event-driven? Of course not. I mean, everyone's free to call event-driven whatever they want. So it's not the purpose of this talk to define what event-driven is. It's presenting the bits and pieces of the bigger picture. And while we're doing that, there's one thing that, in my personal opinion at least, very often, not to say always, remains unnoticed or is overlooked when we talk about event-driven systems, and that's passive-aggressive events. And now you may be like, what? Like, you're making up terms here. Okay, I'll give you an example so you understand what I'm talking about. Here is an event. Joe ordered to paint door 28 in red. So what is that event telling you? And how does it comply to the general rules of events processing that we discussed earlier? So essentially what you see here is a command. It's a message that is targeted at a particular recipient. It may be one, it may be a group of people or maintainers or systems or whatever, but it is a specific request for a specific action to be carried. And in most cases, it will require at least an acknowledgement response. It will at least require the recipient of that message to say, yes, I will, or no, I will not. It's not a notification. It's not an information that something has happened. It's a request to do something, right? But let's take the other example. So Joe asked, what is the color of door 28? So is that an event? Well, I mean, yeah, if you are interested about what Joe asked for, it is an event, but essentially it's a request for information masqueraded as an event. And that's essentially a query. You send a request for information, and in this particular case, you absolutely require a response, right? Because that's the whole purpose of it. That's why you asking him so that you get the information back. But when we were talking about events and event notification, event carriage, state transfer, the core concept was that there is no such thing as response. So how would you implement that with events? What you could do is you could have a queue that you send those events, and then you would have another queue where you say you send another events, which are essentially responses, right? But what if Joe asked about the colors of all doors? Like how many queues you have, who's going to listen to what? How do you indicate that that event makes no sense unless there was another event that actually requests that event to be in that queue, right? And believe it or not, in my experience, this is where a lot of event-driven systems become tedious and complex, and people go like, oh my gosh, like I need to send event here, but this system is going to send event there to respond to this event, and it becomes super complex just because they fail to realize one thing: those are not events. Those are either commands, a request for an action to be taken, to be executed, or a request for information that explicitly requires a response. Those are different type of messages. So how we can handle this? So remember in the beginning I said that I'm particularly talking about message router and not an event router. And the reason is because if we model events as messages, there's nothing that prevents us to model other things as messages, right? Particularly commands. You can have a different message type, which is a command, which is not an event. It's not a notification, but it's a request to do something, right? And that command can be routed to a component that can actually handle that command, right? And do something with it and eventually provide some response. That response may be knock, or it may be like, I need more information, or whatever your domain says it needs to be, but it's a different type of message. It's a command, it's targeted towards an executor. You can also provide the same type of flow for queries. You can send a query message, says I'm requesting this information. Now that is routed to whichever component actually can answer that query. It can be one component, it can be multiple components, it can be distributed, like you send it to what X amount of components, whichever response first, and you get the result. Or you can do what we call scatter-gather queries, basically send it to, I don't know, whatever amount of receivers, wait for all of them to respond, collect the responses together, and turn that as a response to the original requester. Those flows are different than the flow that events follow. You can model them with events if you want to, but it becomes super complex as the system grows. So if you're familiar with CRS, you may be wondering, is that what I'm talking about? And partially, yes, it is. So yeah, CRS is exactly the thing that helps you in this case. You separate the commands and the queries and the events. So let's briefly talk about CRS for those who don't know what I'm talking about. So the idea of CRS, the abbreviation comes from command query responsibility separation. The idea is that you have distinct models for commands and for queries. And it is attributed to Greg Young, who first started talking about it many years ago. When Greg started talking about it, the original idea was to just have separate classes. So you have one class which only has the methods that persist data and update data and delete data and do modifications, right? And you have another class which only reads and returns data. It's not allowed to change the data in any way, right? And so he was talking about separate reads and write. Now, over the years, that concept evolved into, it got combined with DDD, with domain-driven design, and evolved into having a separate domain models. So when you have a domain and you want to model it, a lot of times people are like struggling for one model. We want that one model that represents the domain. And if you take a step back and say, wait a minute, we may actually need more than one model. A data model that is convenient to work with for storing data and updating data and persisting data may be completely different from a model that allows to easily retrieve data or get the pre-processed data, right? So for example, you can have one model for storing, and then you can have one model for reading when you display on a website, another model of reading when you generate PDF files or report to third-party systems. You actually may be better off having multiple models of your domain, and each of them representing the data in a way that's most convenient for the given consumer or producer. Depends on which side of the equation you are. The question is, if you have multiple models, how do they sync between each other? Like, so if I have a model here that stores and updates data, and another model here that only reads data, so how that read thing knows what the right thing stored somewhere? And the answer to that is events. I mean, the right model doesn't operate, does something. Something happens because of action has been executed, decision has been made. So it notifies whoever it needs to notify via an event. And the read model receives an event and says, oh, this happened. Okay, so I'm going to store this data in whichever place it's convenient for me. It may be a database, maybe a file system, and maybe whatever it's convenient for me. Some other read model is going to receive the same event and store it in some other place convenient for that read model. So you basically use events for communicating between the write model and the read models. And so this is what you eventually, but we already discussed this event, right? You discussed how to do all this notification producers and consumers, so that's already in place. So if you do this with the approach that we already discussed, you pretty much have the full picture. Like, you have three types of messages as commands, queries, and events. And you have the notion of roles of consumers and producers, so you can know what's going on which side, right? And then you have something in the middle that's capable of routing messages according to the logic that exists in that given domain. And that's what we do at Axonic. That's what we call the event-driven. When we at Axonic say event-driven systems, that's what we mean. And that's what we help people build. And how we help people build those things? By providing them with two things. First is that box in the middle. And that box in the middle in our offering is called Axon Server, or as of a month or so now, we have Axonic Cloud, which is essentially Axon Server in the cloud. So basically, it's a thing that can do all those things. It can route messages, it can store events, it's a fully functional, efficient event store, clusterable. Like, the Axon Server actually comes in two flavors. There is a community edition, if you will, a standard edition that's free, and there's an enterprise edition that comes with clustering and a bunch of enterprise features on top of that. So it can do all those things that we discussed. It distinguishes commands from queries from events. It knows how to route them. It works with the components. It's configurable out of the box. You just put some annotations on your components, and it knows which one's which and what to do with it. The same thing works in the cloud now. There's a free plan on the cloud. I'm not going to give you the exact data, like how many messages you can do for free at the moment, but please check it out. I'll show you the links in a while, so you can check it there. So that's our contribution to building these types of systems, and you can do it for free for a start, and then you can upgrade when you need it. The other to the paid version, to the more advanced version. The other thing that we try to help people with is the arrows. Like, that's my favorite thing when I watch presentation, is like, you draw a box, and you put an arrow in between, and it's like, yeah, this thing talks to this thing. And then you go to implement it, and it turns out there's a bunch of things that you need to take care of, like serialization, like security, like God knows what, right? And protocols, and conversions, and whatnot, right? So we also have this thing called Axon Framework. An Axon Framework is essentially doing the the communication part. It hooks it. It doesn't have to be connected to the Action server. Actually, if you don't want to use an Action server, you can just use Action framework and connect your components through the framework directly, right? And it comes handy actually if you don't want to immediately start distributed. If you have a monolith and you want to keep the monolith for a while, you can start building it with Action Framework, or you can start transforming your code to use Action Framework. So all the communication goes through messages, like commands, queries, and events. And then at some point in time, when you're ready to go distributed, you just flip a switch and says, now instead of using a local communication inside the JVM, actually go use Action Server and transfer this through the wire, right? Or if you want to be, in some particular cases, some pieces that cannot go through the wire because of performance reasons or whatnot, you still can use the framework directly. But the framework essentially helps you with wiring things and defining things. It's a Java-based, so you can use it with pretty much any JVM language. Surprisingly, a lot of people that I talk to use it with Kotlin. I'm not a big fan of Kotlin myself, sorry about that, but I know Kotlin is getting pretty big these days. We even have some folks using it with Scala, which for me is a black magic, but people like things. Anyways, any JVM language that comes to mind would actually work. We are now in a process of building alternatives for Action Framework for different technologies. Things like .NET comes to mind. I'm not going to mention others to not raise expectations, but we are in the process of supporting more languages. Currently, it's JVM. Any JVM language is fully supported. And it's very easy, very convenient. You just say that component is a command handler, and that component is an event handler, and the system knows how to route things between components. Yeah, Action Framework is open source. You can download it. The source code's on GitHub. You can just use it as a dependency in your Maven Gradle project, and use it any,
Basically, these are limitations, Java limitations, or something else.
So it gives you several things. It gives you the declarative part, so you can say which of your component is what, right? What role it plays in the domain, whether it produces event and consumes event and whatnot. So you can register them with the framework, and the framework knows how to distribute the messages, who's supposed to receive them, and whatnot. But it also gives you the three buses. It gives you an event bus, and a event bus, query bus, and command bus. And so you can use those to send commands, events, and queries, respectively, to different components. So basically, it's very convenient. A lot of people are actually using this with Spring Boot. Again, not my favorite thing, but I understand that is it's a very popular, widely used. But if you're using it with Spring Boot, for example, all you need to do is just inject a command bus, for example, and then you say command bus send command, right? And yeah, sorry, you're right. Inject
is in the right.
But I think they have an alias for inject as well.
Yeah, they support injectors.
Okay, auto-wired, thanks. Yeah, so it become clear I'm not a Spring fan. But a lot of people are actually using it with Spring and Spring Boot because it's very convenient. You just inject your components and then say, I want to send the command. And then it's some other component is declared as I can process this type of commands, right? And the system takes care of routing things, and then it can configurably scale this into multiple instances, distributed systems, and whatnot. So that's what the framework actually gives you, right? It also has a bunch of plugins. So you have plugins for tracing, you have plugins for Kafka, a lot of things.
Then if you want to have, so you must build your system on different component level to be able to scale on specific components, right?
Right. So what we recommend, and if you go to the Axonic website, you will actually, I'm going to switch this here so you can see the URLs, so you don't have to Google them. But if you go to the Axonic website and you start reading about this, you will see a big picture about domain-driven design. So we are big fans of domain-driven design, and we recommend people to model their domains following the domain-driven design principles, right? And that means bounded context. That means aggregates and value objects and whatnot. Entities, and when you actually start doing it this way, it becomes very apparent what is what. Like you can look at the component and see, okay, oh, that component is an aggregate, and those are the entities inside that aggregate, and those are the value objects, and then you can immediately see, okay, that aggregate is actually receiving these types of commands. Right, that's how you communicate with the aggregate. So if you want to, you don't have to go into DDD stuff, but because you just can have event handlers, right? A class that handles events and a class that sends an event. But if you actually go and do the full domain-driven design, which the framework supports in a nice way, it becomes very clear. You just look at the system and you know which component does what. And that's another thing that the framework itself can help with. I'm going to give you a few more links, and now I'm going to have to move so you can see them here. And if you want to take pictures, I guess the slides and the presentation will be shared so you can see it from there. But there are a few more things. We have released this year a thing called Axonic Academy, where we have courses about not only about our stuff, but also about domain-driven design, CRS, event sourcing, and all those concepts. So highly recommend to see that. There are 2 free courses, and we're currently adding more courses, which will be paid ones, but will be relatively affordable. Axonic Discuss is the platform to talk about things. Not only our products again, but anything domain-driven design, event sourcing, CRS. A lot of our engineers hang out there and answer questions, so it's a good place to be. If those are the topics that are of interest to you. Axonic Initializer is, if you know Spring, start Spring, whatever the thing it's called, that you go on a website and you tell what dependencies you want, and it builds a project for you. Well, that's the same thing for Axonic, for Axon Framework. You can pick the plugins, and it's going to provide you with Maven and or Gradle project if you do quick start on Axonic-based application. And my colleague Sarah Torrey is doing, I'm not sure you can see it here, but she's doing a podcast called Exploring Axon, and where she's talking to quite some interesting folks in the whole domain-driven design, CRS event sourcing space. Very worth listening, in my opinion. You have the links on the slide, and that's all I have for you today. So thank you very much for attending. I'm open to receive and respond and answer questions. Thank you. And please send feedback, Twitter, email, whatever. You probably can easily find me somewhere in the internet. Whichever channel platform works for you. Please let me know what you like, what you didn't like, what should be improved. If you disagree with anything I said, please reach out. I don't claim to be the only person that knows it all. So criticism is also welcome. Thank you again. Questions here? No more questions here. Do we have questions online? All right. So then I guess we're done for today. Have a great evening, everyone.
Thanks everyone for watching. Thanks everyone for coming. Thanks everyone for being safe and keeping us safe. And yeah, we're back. And Merry Christmas, Happy New Year. See you next year, online, offline, in person. And yeah, see you.